All right, hey guys, welcome back. Make sure we're going to go through each group one at a time, have a representative report out or discuss what you all talked about. Um, Make sure that as you go, you're filling out your chart or writing some notes down for each of the different ones. And good news, you all get 10 points for this, basically just for participating. And I'll put that in under your participation grade online. So we're going to go in a specific order. And it's basically the order I assigned them. So we're going to start with carbohydrates first.
Okay, let me put that up on the screen. All right, can everybody see that? Cool. Carbohydrates. What is it? Well, it's different types of sugar. Few examples, we've got glucose, lactose, maltose, fructose, sucrose, lactose, starch, and cellulose. A lot of those are really important in different foods that we've got, like, for example, fructose. Fructose is in a lot of different foods that we eat that are like sweet and stuff. And maltose, you've got maltose is used in like hard liquor and beer and stuff like that, which a lot of people drink. And then glucose is kind of it's two different fructose that are put together, and you've got glucose, and the body just breaks that down into two fructose molecules. So why is this important? Because it provides the body with energy. And there are, if I can get this up on my screen here, there's a couple different types of things that show you what the structures look like. But I'm not seeming to be able to find it. So just a second.
Just real quick, I want to clarify, he said something backwards. Glucose is actually the most simple version of the carbohydrates. It is the building block to all of the other structures that he mentioned.
Oops. Okay. Can everybody see my screen now?
You have to stop sharing and reshare.
Oh. Okay. Stop share. Reshare. Here we go. Okay. So you've got a few different types of structures here. With here's glucose. It's got like six of these different things that kind of attach to each other. Same with galactose. And then fructose is kind of like a five-sided little thing right there. Maltose is an example of something that is attached by two of these molecules right here, the glucose. I think, hold on. No, it's attached by two different galactose molecules. So that's kind of like one of those more complex carbohydrates, whereas these are simple carbohydrates. Anyway, that's all I got.
Thank you, Grayson. We'll talk a little bit more about this when I give a brief overview here after you guys get done. Good job. Next is lipids.
Sorry, I'm getting my screen ready. Is that good? You'll see that? Okay. So we found that lipids are a dietary source of energy for animals, and they contain 9 kcals of energy compared to the carbohydrates 4 kcals, which makes it extremely efficient for animals to store the energy. So I would say that's why it's important, is for energy storage. The 3 types of lipids that we found were volatile fatty acids, long chain fatty acids, and cholesterol. Volatile fatty acids are decomposing organics and generating gases, methane and carbon dioxide. Some examples of these are vinegar, Swiss cheese, and body odor. The acids are acetic, propionic, and butyric. The long chain fatty acids are saturated in phospholipids, which is like aspirin. And for phospholipids, they are major components of cell membranes and membrane organelles. And then cholesterol, which we know a lot about cholesterol because it's something that we have in our diet as well, but it can also cause a factor in heart disease at a young age. Lipids are basically a carboxyl or a carboxyl group. So actually I'll do the same thing that Grayson did. I have to stop sharing and then reshare. Okay. So here you see the carboxylic acid, which is this carbon connected to this OH, double bonded to this O. You see it's the same thing for each acid. And then based off how many carbons it is attached to, determines if it's acetic, propionic, or butyric. So that's for the volatile. And for the common fatty acids, you see the same thing. It's the carbon connected to the OH, double bonded to the oxygen. And these obviously have a lot more carbons that they are attached to, which makes them a little bit longer, considering the name. And then the cholesterol is a lot more complicated. So I am really not going to go like too into it and act like I know what I'm talking about, considering I only took chemistry for a couple semesters. But basically a lot of carbons, and here's your OH group down here. But yeah.
Thank you guys. Good job. And cholesterol is a little bit more complicated than the scope of this class, so don't worry about picking that one up. Just know that it is part of the lipids. Right. Next, we'll move on to proteins. Thank you.
All right. So we had protein. Overall, protein is the 4th major class of nutrients, and it is assembled by a chain of amino acids. Some examples come from beef, milk, eggs, soybeans, and corn. Some amino acids themselves is like methionine, histidine, and arginine. They are a source of energy and a principal structure in making muscle tissues and the matrix material to make bones. And it also makes up certain hormones. Yeah, and on the bottom right, you can see the chain of amino acids that make up the protein. And then the top is just some more visual examples of protein source items.
Good. Thank you. All right. Yes.
For some reason, I thought I was protein, and that's what I ended up doing.
That's fine. You go again, and then I'll cover what was missed.
All right.
Tell us some more. What do we know? What do we need to know about proteins that she missed?
She pretty much got everything, but that they're made up of a bunch of different essential amino acids. So there's some proteins can be like made up of just like 3, or more complex proteins can be made up of more.
Yeah, good. No, I was going to go a little bit more in depth, but that's fine. Good job. And like she said, the amino acids, especially in animal production, is important for building muscles during the growth. That's why we have a lot of protein in younger animals. When the animals are growing, they need more protein to build the muscle, as well as other functions within the body. All right, vitamins and or minerals, whichever one is next and last.
I'm minerals. I can go.
Perfect.
Okay, so minerals are inorganic elements that are required to sustain life. And there are two categories of minerals, macro minerals and trace minerals. And you need relatively high amounts of macro minerals. And they include sulfur, potassium, calcium, magnesium, and a couple others. And they're used for like bone formation, muscle growth, mainly big body functions. And then trace minerals are in lower concentrations. And they include iron, copper, zinc, and iodine. And they're needed for producing white blood cells, hair and wool growth, and iodine helps the thyroid gland function properly. And a deficiency of minerals can cause lapse in body functions. And one example of this is milk fever, which is caused by a deficiency in calcium.
Where do minerals come from?
They're on the periodic.
It's kind of a trick question. They're just kind of here. They just kind of already exist, though we can make some that are synthetic. Minerals basically already exist in our environment. You could, if you believe in God and say God created the world, you could say God created them for us. Otherwise, they just kind of are. I think it's a fascinating fact. All right, perfect. Any questions before we move on? Next, what I'm going to do is briefly hit all of these minerals in my presentation, just to add on little bits where I want to make sure we emphasize for this course in terms of livestock production. Maybe I'll get there. Things going, guys. All right, so this is basically just our introduction to nutrition lecture. Nutrition itself is just the study of how our body uses the nutrients we get to sustain life. Same thing for livestock. It's associated with health, well-being, physicality, and their ability to, well, their susceptibility and ability to recover from a disease. It's really important to the livestock industry because 45 to 75% of the total cost of operation of a production can be directly related to feed. We do have all of our nutrients that we just discussed, and they are important for maintaining reproduction, growth, and lactation, as well as other metabolic regulators. Now, you will learn a bit about metabolism in your module in the very last section. They're either dietary essential or dietary non-essential, and if they are considered dietary essential, they must be a part of the diet. So essential means it has to be in the diet. The body cannot synthesize that nutrient on its own. These are the classes we just discussed, and I will go through them each. Well, these are the classes again. We have nitrogen, which are the building blocks. Nitrogen is part of amino acids, and amino acids are the building blocks for proteins. And so these are just some of the amino acids that are in the diet. These are all essential. So methionine, arginine, threonine, tryptophan, valine, histidine, isoleucine, leucine, lysine, and phenylalanine. These are ones that are essential nutrients. We then have fats. They are made up of fatty acids. And the essential fatty acids are linoleic, linolenic, and arachidonic acid. So these three. Vitamins are broken down into two different categories. They can either be fat soluble or water soluble, which means that that is how they kind of transport or are moved around within the body. So these are just lists of the two ones. A, D, and K are all fat soluble, meaning that they can easily cross through and associate with fat, whereas water soluble, obviously water. And then we have minerals. They're either macro or micro. So macro means they are needed in larger quantities, which is relative. Here's a list. I'm not going to read them to you. And then we have micro minerals. So smaller quantities, but they are still essential for the diet. All right, water. So water is a nutrient. Oftentimes people do not think of water and they think of nutrients, but it's the most important nutrient that exists, that an animal or a person must need, because without it, they will quickly die. In the body, it is used as a lubricant. It regulates body temperature. It is a solvent for solid components, like we just discussed. It transports things throughout the body, especially in the fluids. And water is necessary for a lot of chemical reactions that occur, as well as those associated with metabolism. We then have carbohydrates, and I really thought I took all these motions off because they make me sick. All right, carbohydrates. As Grayson discussed, they're sugars, starches, and cellulose. And these are the ones that we mainly use to provide energy to animals. So carbohydrates provide energy. Carbohydrate structure are made up of carbons, the C's, hydrogens, the H's, and oxygens, the O's, CHOs. Every time that a C passes through certain metabolic processes in the body, it could create X amount of energy. And so a lot of C's mean lots of energy. So grains, when we feed them to livestock, they have starches and sugars that are very easily digestible. These tend to move through the system much more quickly. And we'll talk more about that later on. Then we have cellulose. This is a main carbohydrate found in forages. And cellulose and some of its close relatives like hemicellulose, those compose the roughages that we feed to especially ruminants, because ruminants can break down those structural carbohydrates. They're a lot more structural. Carbohydrates are what's most commonly fed in all of feedstuffs. So this is glucose. It is a simple ring, 6-carbon ring, and it is basically the building block for everything that we're going to mostly be concerned with within animal science. And glucose builds into cellulose, and this is part of the plant wall. So we have the plant, which is made up of cells. Within the cells, the cell wall is made up of these cellulose fibers, and they're all crossing there, and they're linked by hydrogen bonds. Each of these fibers are what we call microfibrils, which is basically just long chains of glucose molecules linked together. And the types of bonding that they have even affect how strong they are. But this is a very strong structure. And this is what we are getting at when we use, or when cows and ruminants use the microbial population to break down their feedstuff. And we will talk a lot more about how a rumen breaks down feedstuff. But the major point is these cell walls in plants, especially forages, hays, the types of feed you typically see, they are very rigid. And so the microbes are a population in the stomach that can come down and break down these complex carbohydrates. Whereas a simple carbohydrate is just like this glucose molecule, a monosaccharide, as Grayson was discussing. Right, we then have proteins. Proteins are chains of amino acids. So amino acids are the building blocks, and they're used as components of tissue, enzymes, hormones, and then other metabolites within the body. If there are excess proteins, the proteins can also be used to provide energy. The protein, like I said earlier, varies throughout the lifespan of the animal. We have higher protein early on when animals are growing and putting on muscle. So those diets are typically formulated with more protein as they become older, enter the... Just one moment. All right, as they become older, enter the breeding stock, that protein requirement is not as high because they are not growing. And then as an animal, if you keep it to senescence, which is when the animal is really old, kind of starting to degenerate, the protein requirement's very, very low at that point. Common ones that we see in the industry are oilseed meal, soybean meal, and cottonseed meal. These are the amino acids. And of course, you do not have to memorize these. You don't even have to memorize a list. The reason I'm putting them up here is because I'm showing you the structure. Basically, all of them will have the same structure. It's a nitrogen, an NH3, a carbon, and a carboxyl group. So all have the same structure. The same structure is the backbone of the protein. And then there's all these different side chains. Well, when the protein is not necessarily being used as a protein, it can break down all these extra carbons and use those as energy. Like I said, with carbohydrates, with each carbon that passes through the body, there's becoming more, certain amounts of energy are being made. And so that's how proteins, if they're not being used for their main function, can go to be used as energy as well. All right. Fats are next. They are made up of fatty acids and glycerol, which is a backbone to basically fatty acids. They're used as energy, and they are also used as storage of energy. Fats have lots and lots and lots of energy, so fats equal energy, basically. They also carry those fat-soluble vitamins that we discussed. I'm sorry, guys. All right, vitamins. They are compounds that your body needs very small amounts, but they're very important. They are either fat soluble or water soluble. And there's not that much to say about them other than that they exist. They're important in various metabolic functions, but those metabolic functions and mechanisms are out of the scope of this class. But so just make sure you realize that we have vitamins, they're necessary, and they are broken down in these two classification systems. Then we have minerals. They are these inorganic constituents, as TR said. They make bones, teeth, and other parts work in other enzymatic systems. They're provided in various ways, including salts, as well as oyster shells is high in calcium, lime, or even bone meal. So bone meal is a byproduct of the animal science industry where they take excess bone and can basically grind it up, break it down, dry it out, and make it be able to use as like a powder substance to supplement minerals back into feed source.